So, Joel, take it away and tell us a little bit about why firmware updates are so crucial today.
Yes, whatever the industry you are, firmware update or today is really a vital feature. Here in the picture, this is an EV charger, but you may develop some other product and you will need some firmware update. Why? Why? Because you need probably in the life of the product, you need to do some bug fixing, of course, in your application or in the VSPs and so on. You will need to do some optimization, and maybe you have also followed the talk of my colleague this week about boot time reduction. And later, probably you will do additional feature that you want to deploy in the field, so that the end user, of course, can be happy with that. And last but not least, and this is enforced today by law, you know about CRA and RED directive, you have to follow and fix vulnerabilities in your system in order to have something that is safe in the field.
So, Joel explained that it is crucial to be able to do that. And the question is, how do we do that? If you've been in this business as long as I am, then you remember just copying files back and forth, using some shell script and hoping that it will not break. Spoiler, usually it breaks at some point in time. And that's why people have invented the AB partitioning scheme. AB partitioning, or active inactive as some others call it, means that you have an A partition for the active root file system or the active operating system that is running, and the B partition, which is for starting out the inactive one, which holds a copy or scratchpad area. Let's call it like that. So how does an update actually work? The system is currently running on the A partition. A new full system update arrives and it gets written without impacting the current operating system on partition A by writing it on partition B. If all of the writing process has been successfully completed, and that's important, only if it has been successfully completed, because otherwise you just abort and live with A happily forever after, then the update mechanism declares, okay, now it's time to reboot. The reboot resets the system. The bootloader now knows, okay, hey, an update has arrived. It flips A and B partitions, now starting into the partition B. And if the boot process successfully is finished, like the system is working again, every checking mechanism that you can think of or that they require has been completed, then the update gets committed, which means like finalized, reported back as successful, it is complete. Or if something bad happens, like your startup routine fails at some point in time, a check fails, or even worse, the bootloader can't boot into the new system, then a so-called rollback happens. So the bootloader flips back a second time into A now, reboots into the untouched original operating system, which means your device is still functional, just with the old software, and then reports back if you have such a mechanism that goes like, hey, your update has failed, you might want to act now, but we're still functional, and the device does not is not bricked, as it's called in nerd speak.
Yeah, something is very important is that the rollback mechanism is a default one. So if the system is even not able to boot at all, Joseph, then it is automatically rolled back by the bootloader. So it is safe and robust.
Yeah, definitely.
When it comes to implementation at the Embedded Kit, we really recommend to split the system so you are able to manage the different part of your device separately. And for that, you have to identify the partitions to update and divide the system into partitions. We have done a small example on the bottom left. Here we have separated /boot, the /boot directory. It is the kernel and the device tree. We have separated the root file system itself, and we have separated the application, your end application, whatever it is, a GUI or something else. And for each of these partitions, we do duplicate to have partition A and partition B for all of them. So now you have designed the system and you have identified the partitions. You have to set up the tool that is required to update the system. You install the tool, whatever it is, and you set up the system, particularly integrating with the bootloader. Here on the left, you have some small piece of code of how we do that in the embedded kit, but whatever it is, it's fine. And once this system is set up and properly integrated, of course, you have to test it to verify the updates, that the updates are properly done or properly rolled back in case of failure. You have also to test, of course, the degraded conditions to test your device. Something that is particularly important is to think about validation of the updates, commitment of the updates to mark it as permanent. It is not trivial topic, and we have to think about the real condition that mark the update as permanent. This can be, for example, of course, network connectivity, communication with a server, availability of some devices, and of course, and probably the end user application that is properly executed on the system. Without that, we can't say that the update is properly done and we should not commit updates. In other terms, just starting the system and having the kernel booting is not enough.
Let's talk a little bit about partitioning now specifically, because having just A and B partitions, that's like the 30,000 feet view. There are two partitions and all of the rest magically falls into place. In reality, it is, of course, not that easy, and you want to have at least 4 partitions by default, with one of the partitions possibly being kind of like hidden. And first and foremost, the hidden one might be the bootloader, because as we're dealing with embedded boards, there often isn't even a real boot partition that you can see in terms of the file system, but U-boot might be living somewhere at a specific location in EMC, and the environment is right next to it. It's not even files that you can see. So we, for the sake of simplicity, we will still call that a partition, because on other systems, there might be a boot partition. So the first thing that you will need to have is the bootloader partition. This is meant to be persistent and not changed except under rare circumstances, which we might talk about later, possibly. Then we have A and B. Though the purpose of those we have already discussed, but remember that by switching back and forth, that implies that all of the data that you put on those partitions is actually transient. Transient means after an update, everything is gone. This sometimes surprises people because they say like, oh, okay, I install this file system, and then I change this configuration, or I install this application on top, or it's just like this data file that I need to put somewhere. You can do that, but remember, after you've done your update, you've completely replaced the root file system. So it is all gone, whatever you did in that specific system. Where do you put those things? And here comes the fourth partition. It's the data partition. This again is persistent. It is kept around across updates, and so Mender puts its configuration data there and its state. You can put your application data there, your credentials, your configuration, whatever. And here comes the parts where things are not so simple anymore, because having an update which still has to deal with old data can mean a number of things. It can mean that you need to migrate data, for example. It can mean that you need to migrate application data. It can mean that you need to migrate configuration data, and you need to be aware of an eventual rollback. So the migration cannot be just simple, straight and forward, and you hope for the best. You need to actually plan for this. And to complicate things even further, if you are keeping log files somewhere, whatever, or application data that might eventually grow at some point in time, your that data partition might even fill up. And then you, as strange as it may sound, your update process might be broken because whatever mechanism like Mender you're using cannot write to the data partition anymore and keep it state safe. And that's why one of the big advices that I can give is understand your actual data, understand the modifications, the mutations of your data, and then possibly split it out into a more fine-grained system than just having one magic data partition where you drop everything into. So, example, if you're using Docker containers, have one partition, or containers as a general, have one partition onto which you place your containers. If you are having log data, create an additional partition just for your logs, so they can't overflow and kill your application. And if you have application data that is not space constrained, consider putting that into a third partition. Mender supports a basically arbitrary number of partitions there. In very strange cases, we can even have them between bootloader and root file systems. I'm looking at you, NVIDIA. I don't know what you took, but it must be good stuff. And make sure that whatever happens during the operation of the system, that your persistent data is understood and kept in such a way that you can actually move back and forth across operating system revisions without breaking the device. Because in many cases, it's not the actual upgrade process that that causes malfunctions for the user. It is actually bad user data or bad planning for dealing with user and configuration data. And this is the crucial part about partitioning, to me specifically, is to plan for using it in a real system and not just saying, hey, I have a B partitioning and that will solve every problem. No, the reality is more complex, and with Velma and Mender, you can plan for this. And as I already have mentioned a little bit, bootloaders. I told you initially that bootloaders are meant to be persistent. Why is that? Because it's a single point of failure. Who of you has ever patched U-boot? Some people usually mention that. Whom of you has written it to the eMMC at some point in time and hoped that it worked? Who of you had a board which didn't boot afterwards anymore? Yeah, see, so that's the problem. Most boards have one starting point for the bootloader, and only a very, very small subsection actually supports redundant bootloaders for modifying or upgrading those. I'm aware of NVIDIA being able to do that, and I think that's it already. Joel, do you know of anything else?
Yeah, you can also rely on the eMMC boot partition itself, so that you can use the boot 0 and boot 1 partition on the eMMC to do such kind of thing. So yeah, bootloader can be also managed like that, but it also requires in this case to customize the program loader, the SPL on the board, which is really specific to the platform. Yeah, for sure.
Yeah, okay. So in a nutshell, the hardware and your earliest boot process have to be actually capable of switching bootloaders to. In my experience, that is usually not the case. If having the possibility to also update the bootloader in a live product, then you really need to plan for it early in your product cycle, because that has some very severe restrictions on which kinds of hardware and which kind of starting process that you can actually use. And I am totally not looking at you secure boot here, because you will have even a lot more fun then if it's a requirement. So my advice here is plan for it and think about it if you might need it, but realistically speaking, I wouldn't call it a hard requirement concerning the bootloaders. As already pointed out, treat your root file data systems, root file systems as transient. Don't put data in there. Having it read only is always a good practice, and understand your user data to make sure that the system stays functional even if something goes wrong with it. Remember, you are handing out the device to somebody who might do with it whatever they want. It basically deals with unsanitized user input all of the time, which is the worst, as we all know.
So if we just want to summarize a little bit what has been told until now, the update is installed in the passive partition. So it's totally safe because we are not running the system on it. It is preparing the passive partition. When it's done, and only when it's done properly, we just have to reboot the system, and the bootloader is informed that he has to switch the partitions. Then, whatever, depending on the results, you have to confirm the update to mark it permanent or roll back on the previous system. And we know, because it is of the robustness of AB partitioning, that the previous system is working and it will not break the device in the field. Of course, in the introduction, we have told about limitations. And the first one that you have understood is that it requires twice the space on the storage media in your devices, because you have to duplicate all the partition or almost all the partitions. But by the way, if you consider your development in general, you are maybe concerned by reducing the vulnerability, reducing the size of the system to not have to update plenty of unused things. And if you do some devices with some GUI using Qt, maybe we also some connectivity drivers and so on, you will probably need about 100, 200 megabytes of space, which is perfectly fine to set up AB partitioning starting with a 500 megabyte device. So this is not a big constraint today. It's very common. Okay. If you have to remember one thing about this topic, separate partitions, keep enough place to host the future updates, so you're not locked in the future in case the system is growing. And of course, as explained by Joseph, keep the data, the user data separated in separated partitions. That's concern logs, but also configuration files and so on, etc., etc. If you are concerned about firmware update in general, or if you have challenge with your Yocto development and you want to speak about your project with us, that's really welcome. Come to see us at the booth. You will see the demos with Welma. You will see also our solution for testing and vulnerability management. And yeah, we are really open to discuss with you of your project and show how it helps. You can also visit the Mender booth.